Hello, everyone. This is again our another recorded discussion for the test of significant difference in relationship. And these are our learning outcomes at the end of this discussion. You are expected to demonstrate understanding of test of significant difference in relationship using classroom assessment scores and decide with the given data what statistical and inferential tool will be used to explain assessment scores. So take note that we are done with the descriptive part of statistics, in which, with the given data, we are just tasked to describe its distribution. Now, if we make inferences about it, this is where inferential statistics takes place. So for inferential statistic, there is always what we called null hypothesis testing or hypothesis testing. So in a statistic, it is not just enough to say there is a relationship. We need to test the hypothesis that there is a relationship. It is also not enough to say there is a difference. We need to have a hypothesis testing that says there is a difference, a significant difference. So in quantitative data like assessment scores, data can be analyzed further through null hypothesis significant testing or hypothesis testing. This is a formal procedure for assessing whether a relationship between variables or a difference between groups is statistically significant. So we have types of hypothesis. We have a null hypothesis and we always have an alternative hypothesis. The null hypothesis will always say there is no effect, there's no relationship. So I would say this is the evil statement in the hypothesis testing. And of course, the positive one will be the alternative hypothesis, which is states that there is a true effect, a relationship between variables, or the difference between groups. Now, an example of making a hypothesis then is in this given scenario. So you design an experiment to test whether active performance makes students happier. To begin with, we make our hypothesis. First is, as the evil statement would say, there is no difference in active participation and less participation. And we would say, for the alternative hypothesis, we would have actively participating leads to happiness of learners. Now, there are task statistics and p-values that we have to consider. Of course, this will tell us how significant or is there significant in the conducted test we have. So every statistical procedures, we have a test statistic and we have a corresponding p-value. Note that all the data that I will be presenting in this recorded discussion are already run or are already analyzed. The importance is how do we interpret this? Now, if we want to conduct the manual hypothesis testing, that would be another interesting topic for another video. Now, there is always a battle in which what the statistical tool I am going to use. So, I hope that you will be guided in this diagram. We have, if your concern is that you are examining the difference in the mean between groups, try to ask the question, how many independent variable? If there's one, or if there's more than one. If there's more than one, then how many groups are involved? Is there only one group? Is there only two groups? Or more than two groups? And if there is two more independent variables, what would be the best? Um, uh, I mean, what are the variables involved? So if you have answered that question, now we'll have the next question. Are you finding the difference between the groups? Or are you examining the relationship between the variables? So there's a difference between the two. When we talk about significant difference, we are comparing means across the groups, within the groups, or between the groups. But when we talk about relationship, we are examining if one variable co-vary, coexist, or it is associated with another variable. So examples of test statistic that can be used when we have test of difference are t-test, ANOVA. We actually have z-test for this. We have MANOVA. But those are just two examples. And we have correlation, regression analysis for test of relationship. All right, now let's proceed to significant relationships. Significant relationships are what I called the beginning of regression, the beginning of causal effect. But note that we cannot say there is a causal effect until we have established that there's a correlation. Also, it's not enough to say that when there's a correlation, one affects the other. We have to run another test for that. Now, these are the examples of variables that may have or may exhibit relationship. For example, children's IQ and parents' IQ. There could be a relationship between. Some would say if your parents are with higher IQ, it is also expected that you will have a higher IQ. But it does not always follow. We also have parental involvement and academic success. Some would say if your parents are more involved in your academic, you will have a perceived higher academic success. And of course, the hours spent studying and your scores in exam. So if you study more, obviously, there will be an indication to that in your score in the exam. Now, test of significant relationship is also called okay, you can have it correlation, you can have it association. There's what we call correlation coefficient. There are two that we use in the statistics. We have the person R, which is represented by R, and we have the Sperman rho, which is represented by that phi letter. So correlation coefficient will tell us what is the index degree of these two variables. Okay, so through a scatter plot, we will be able to know the relationship between our x and y variables. Note that earlier, before the diagram, when we talk about relationship, it involves more than two or more than relationships. So we always have that independent and we have that dependent variable. Other authors would say you can call it as predictors or outcomes. So again, we can make use of scatter plot to illustrate the relationship between two variables. And these are the direction of the relationship. So either we have a positive correlation or we have a negative correlation. So for example, we have as you study more, of course, you will have a great score in the exam, hopefully. So that's a positive correlation. However, if you expose more yourself in social media than studying, of course, there will be an indication to that in your test results. So that will be a negative correlation. So the keyword there is that as x increases, the other also increase for positive. However, for the negative correlation, as x increases, the negative variable decreases. Now, this is the one that I have mentioned earlier in the previous slide. This is the person R, and this is the Sperman rho. It's important to know that not all data can be treated as person R. We can only use person R for linear type of variables or continuous type of variables such as interval and ratio, and Sperman for nominal categorical type of data. So these are examples of scatter plots that shows a positive and negative correlation. So obviously, as you can see here, this one is so The value for this is 0.85, and the value for this is negative 0.94. So you can see the other is positive and the other is negative. There's also what we call no correlation at all, when the scores are scattered around the scatter plot, like it's scattered. Oh, unlike to what we can see here, there seems to be a movement of the scores around the center of the line. That's why we can say this one is positive and this one is negative. Now, you can use this as a threshold to interpret the result. So as you can see, there is a very low to negligible correlation. There is a low correlation between 0.2 to 0.39 and so on and so forth. Now this is also true for negative correlation. These are examples of it, more examples of scatter plot. So as you can see, there is a perfect correlation happening, positive perfect correlation. So as if you will observe, as the points are scattered, of course, the R value is decreasing. That is because seems to have no, this is already a negligible correlation. So it seems to have no correlation at all. All right, so how do we interpret correlation test? So we have this one. This is already a analyzed data. So we have a learning attitude and scores in math test. But sometimes literatures would say that learning attitude, if increased, would also increase the academic success, such as scores and tests of the students. So based on this table, we can say that there is a moderately positive correlation. Or can you say that in the table, what will be the indication that you would say there is a significant relationship? Yes, there is a significant relationship. But the question is it significant? To answer that, we proceed to the p-value. The p-value is lesser than the alpha. If the p-value is lesser than the alpha given, that means to say the test is significant. Or we reject the HO. Because the HO for this test is that there is no significant relationship between learning attitude and scores in test. So if we reject that, we say that there is a significant relationship between learning attitude and scores in math test. So an increase for the learning attitude positively would also have an increase in scores of the students. Now, that is for test of significant relationship. Now we proceed to comparing means. Now, please do not be confused. When we say comparing means, this is also test of difference or significant difference. So we can have, depending on the sample we can have one sample, two sample, or more than two samples. For more than two samples, we can have ANOVA or MANOVA. The meaning of this is that this is analysis of variance, and this one is multi-analysis of variance. Now, what do we use this test? When do we use one sample? When do we use two samples? Or when do we use ANOVA or MANOVA? That will be our focus for this subtopic. Now, when to use one sample, z-test or t-test? Now, there's a difference between t-test and z-test. When we say z-test, we're referring to when the n is greater than 30, and when we say t-test, we're referring to the n is lesser than 30. For SPSS or JASP, you don't have to calculate, you don't have to look for the value of n. Automatically, the software is already built to identify what is the n, and they will just be using the exact test directly in the application. So when do we use it? If we are looking for the difference between a mean, which is a sample, to a known value already. For example, the classroom score of Sampaguita grade 7, which is the sample, will be compared with the existing data from the population of all grade 7 learners in the region. So that means to say this is already an established score. Okay, so we have one sample, which is the grade 7 sample mean, and we are just comparing it to the unknown population already. An example would be this one. Let's say math scores. So we have here. So again, you look for the p-value. Usually the tests are always conducted a significant level of 0.05, unless if it is a medical study, we will be using the 0.01, or as much as possible lesser than that. Now here, it would indicate that there is a significant difference, and this difference of negative 6.857 is significant. Okay, so that means to say, with a p-value of 0.001, less than 0.001, the 20 that we used to, this is the population, the 20 that we used to compare with the math score of the grade 7 is significant. Okay. How about the two sample t-test? When do we use it? So two sample can be paired or independent. So pair sample can be used to compare two samples with each observation in one group or one sample. Example would be an experimental study, scores before the remedial class and after the intervention was compared. So take note, we have just one group, but there are two samples in that group. That's why we use a paired sample t-test. Example would be the pre-test and the post-test. So again, it shows that there is significant difference, and that we can say that pre-test differs, the score in the pre-test differs substantially with the post-test scores. Now let's proceed to independent samples. When we talk about independent samples, you can use this for two different groups. For example, control and experimental in your study. So we need to compare a different sample in each different groups. That's why we call it independent sample. Example, analyzing the difference in academic performance between two schools. You can have two schools. One could be a control school, another could be an experimental schools. Okay, so here's an example of an analyzed or a data already that is from the JASP, which has already been analyzed. So we have a p-value here. That means the difference is significant. The degrees of freedom is actually just our n sub 1 plus n sub 2 minus 2. So that's the first group, the second group minus 2 because we have two groups. And that would tell us that we have this one. Let's say, for example, this is the groups we are comparing independently of each other. Of course, you cannot have a student that is under your control and you have under an experimental group. They should be independent of each other. So here, that's why we can say that the mean difference, we're going to subtract it here. That means to say, let's say, estimated value for this is um, minus 46.60, the answer is negative 13.5. So this difference of negative 13.5 is significant. So what does it mean? Experimental group score higher than control group. It's safe to say that they score. Sometimes there's a difference, but it's not significant. That's why we have to look for the p-value always. However, if the p-value here, just for example, is equivalent to 0.25, then we can say that this 13.5 difference is not significant. Okay? I hope that we were able to understand that. Now, how about with more samples? So we have earlier, we have one sample, two sample. Now, how about we're dealing with more samples? If we're dealing with more samples, we can use ANOVA, or we can use MANOVA. MANOVA is multivariate analysis of variance. Good. ANOVA would be enough for us to explain that we can still look for the significant difference, even if it is more than two. So an example would be, what effect, if any, does grade level have on problem-solving efficiency? Of course, our null hypothesis would say there's no effect of grade level on the problem-solving efficiency. And the alternative would be, at least two groups have the significantly different level. So a data was analyzed, and these are the results. So we have groups. Degrees of freedom is just how many number of groups minus 1. That's why we have 2 here. And these are the sum of the squares, the mean squares, the f value, and of course the p value. The p value is where you're going to analyze if the significant difference is significant. So however, when we check, it's just still lesser than 0.01. So we can have the post-hoc comparison. When we have post-hoc comparison, by the way, it's if you found that there is a significant difference, you conduct the post-hoc analysis. But if this value is greater than 0.05, then there is no need for us to establish the post-hoc analysis. We can just definitely say with this value, there is no difference. There's no significant difference. But however, again, going back to our value, we can say that there is a difference. Okay? Now, with our post-hoc analysis, our post-hoc table, here we can understand which group scored different and which group did not. We always look to the Tukey value, the P Tukey value. There are a lot of assumptions that we can use, but the commonly used one are the Tukey. There are other tests also, but the commonly used one is the Tukey test post-hoc analysis. So as we can see here, it's safe to say, based from this table, that first year and second year significantly differ. Their what we call this problem solving skills significantly differ. The first year and the third year as well significantly differ. However, the second year and the third year seems to be the same, is equal. Why so? Because our p-value is 0.19, which is way greater than our 0.05 threshold. So as you can see, this mean difference between these two groups is significant. However, this mean difference between second year and third year is not significant. What does it say? There is a difference in terms of grade level when it comes to problem solving. So maybe because second year or third year are already exposed to more problems compared to the first year. And that would be a great implication of this table. So I hope that you have learned something about test of significant difference and test of relationship. Thank you so much.